Chip, thanks for being here. You are an OG venture capitalist.
Oh, well, thank you. It's
back
great.
when it was a cottage industry, I guess. You started 30 years ago.
It is great to be here. As you all graduated from HBS, my year in HBS, I was one of 800 that became a venture capitalist. So it was a teeny industry at the time.
Wow.
And obviously now much about 100 times bigger, global, and we're on the cusp of the next big revolution, which is going to be amazing.
Yeah, so I imagine you guys, or I know you guys are all in on AI. You guys have a few theses right now. And so tell us what you think the next, maybe 12 to 18 months looks like on really the future of agentic applications.
Yeah, so we're really focused in three big areas. So one is agentic applications. And so switching the paradigm from putting a co-pilot into a SaaS application into applications that can actually get real work done. And so, the jobs to be done framework that we were chatting about earlier, 100% relevant, and we can dig into that. But those applications will be both horizontal, so crossing industry boundaries. So we have a company that's building agentic application for cybersecurity engineering as one example, or they'll be vertical, going after domains that are narrow. We have one that's an agentic application in the capital market space, and so we think about those opportunities. It's a combination of how big is the space in terms of number of potential customers, and then how much value can you create over time. And we're huge believers in the opportunity set there, and think that there's several $1 trillion of SaaS revenue that could potentially be disrupted, and then add on top of that the opportunity to free up human resources to do more interesting and creative things. And so there's really large market opportunities to pursue there. Second big theme for us is really an area we've been investing in and around for 15 plus years, which is all the developer infrastructure that supports those applications. And so as you know from building yourself, completely different way of thinking about software development and non-deterministic applications. And so what are the evaluation frameworks? What are the security frameworks? What are the reliability, observability, all the classic IT illities we think need to be rethought? And this happens really with every big platform shift. You see opportunities for new companies to move and serve the needs of their developers and operators in a much more effective way. And we were very successful in investing behind that theme in the cloud, in the rise of the cloud, 10, 15 years ago with companies like MongoDB. And
you guys nailed that one. That was a very non-consensus bet.
I stood on a stage at Stanford in I think 2008 or 2009, and there was 500 IT people in the audience, and I said the public cloud's going to win. And that was a wildly controversial
They were
opinion.
like, boo.
Yeah. And afterwards, everyone's like, the security issues, the reliability issues, the performance issues. And I'm like, trust me, the public cloud will win. And that was 100% right. And it was because there was such an emphasis on all the things that went around the public cloud to make it performant, to make it reliable, to make it secure. And then obviously the clouds themselves advanced at a pretty rapid rate. And we see the same thing happening in the AI space. And so that's a very exciting opportunity. And then the third big theme for us is maybe easiest to describe, hardest to figure out how we go out and find those companies. But every time there is a big new enabling technology wave, it tends to create the opportunity for new applications. And so we call these AI native applications. And so it's the things that you never knew you needed until you got, and then you're like, how did I live without Uber?
Right. Exactly.
And you have Uber because you have a GPS enabled, always connected computer in your pocket, and we know that there's going to be those kind of applications. And so founders who are thinking really creatively about the capabilities of AI, not necessarily today, but a year from now, 2 years from now, and what that potentially enables in terms of end user experiences, both for consumers, prosumers, SMBs. There's going to be sort of a rise of opportunities across the landscape in those spaces. And so those are the three big themes we're pursuing. What we're not investing in is sort of clear, for technologists that are listening to this. There's all the building blocks that sit underneath the application layer and the developer layer. And so
you guys don't have $1 billion.
We don't have $1 billion to put into a new foundational model. And you're seeing this obviously in terms of model performance. There's a tending towards convergence in terms of underlying performance, and so So we think that's an incredibly important layer, obviously, but one that over time will become somewhat less differentiated. And so not only not having $1 billion, but we feel like it's going to be an important, but maybe not necessarily where all the value accrues in the market. And then obviously we don't have tens of billions of dollars to be thinking about the chipsets, and there's huge opportunities there. You're going to see a segmentation of the NVIDIA, your old world.
Yes.
I don't know if there's a controversial take, but but you're going to see a segmentation of, you can't imagine a world 10 years from now where NVIDIA has 95% market share.
Right.
And, so we're investors in a company that is enabling AI models to run hardware independently, as one example. And there's obviously people building chipsets that are going to be very focused on inference, and others that are going to be very focused on training, and others that will be very focused on edge, and so you're going to see that market, I think fragment and segment, and there's going to be a lot of opportunities created in there, but a little bit outside at the core hardware layer, a little bit outside our area of expertise.
So is your guys' bucket 3 basically the surprise me bucket?
It's totally a surprise me bucket, and it's the classic, it when you see it. And we have a few forays in that, but I think the capabilities are emerging and developing so quickly that, if you think of November 22 as when we sort of started this boom, we're 2 years in. If you rewind to the first wave of the internet, I made my first venture investment in December of '94, which is the year and month that Netscape launched. Fast forward to December of '96. All these companies that we live and breathe and use every day now, Amazon had barely started, Google hadn't started, and so we think those new application layer companies are really just emerging as the technology ends up maturing to a point where you can feel there's a level of reliability and performance that enables what you're trying to build.
Totally. And you mentioned inference, Siddhant, and you mentioned NVIDIA, so I got to post it in here. Curious if you could share your thoughts on the direction of inference time compute being sort of the next S-curve that we're climbing up on, and see if Chip disagrees.
Yeah, so I think you made a very important point. NVIDIA, commanding 95% market share is an anomaly, and it's commonly held that we're not going to see that for the next 10 years, and I would generally agree. But I think an important factor to keep in mind is that they have 250,000 developers on the CUDA ecosystem,
right?
And as you correctly described, there are two halves of the world. One is training and one is inference. If you were to say NVIDIA cannot command 95% of training market, even for after the next 5 years, I would disagree, just because of their lead on training. But on inference, but on inference, 100%.
Right.
Because inference, I believe, is about to be commoditized, essentially because you can get CPUs to do inference. In fact, I don't think GPUs are good at inference. GPUs are more designed for taking the heavy workloads of training, but you can optimize a CPU to do inference. And inference is the next wave, of course. As you mentioned, agentic AI gets adopted, AI native becomes the thing. So we will see a lot of competition there and a lot of push. And it's everybody wins in this game because as this market gets commoditized, as there are more players, the cost of running inference goes down. And it's the application layer companies like Blitzy and others who are the winners in this, and it's ultimately the customers, because you're going to get these high quality outputs. You're going to get the quality of life improvements from AI, and it's not going to cost your wallet.
No, so I 100% agree with that observation. So do you think the inference winners are going to be traditional CPU architectures, or are they going to be companies like Etch that are going to really design special purpose inference chips for transformer models?
I think it's going to be both. I think there's going to be, we've seen like special purpose chips for transformers. We've seen also, other kinds of ASICs designed for specific use cases. And I think the market is already fragmented with companies like these, and it's going to work. Google has their own ASICs, and they use those successfully for various workloads across the company. There are thousands of applications of those. Talk about medical devices. There are like countless applications. We don't even go there. But I think it's going to be a twofold war. So at one point, in the cloud, where you have like high volume, high intensity data that needs to be processed, and you need to run inference at scale, I think CPUs have an unfair advantage there, because we are riding on the cloud wave already, and the cloud wave has been all CPUs. And for the specialized, use cases, again, they are higher value, so they are not as commoditized as the cloud wave. So in that cases, I think the specialized architectures are going to do well. But the trade-off there is, if your architecture is specialized to, let's say, matrix multiplication, or it's custom built for the transformers architecture, then as soon as a new architecture comes in, like we've seen, there's waves about liquid foundation models, there's other kinds of architectures that are going. And I know for us with certainty 100% that AGI is not going to be based on transformers, because transformers are, they compete based on tokens, and they are not capable of learning new skills that you would need for AGI. Right. So the risk there with the specialized models is that you're going to have, to adapt quickly as architectures change. So you're going to have to be 5 steps ahead of the wave. But it's not easy to adapt because it's hardware, and it's a multi-year design cycle and test cycle and build cycle, and then it's an integration cycle to get your hardware out and fit into the company's systems. So that's the trade-off over there.
That's a sound analysis. I would tend to agree with that. You embedded in there, by the way, a very interesting comment, which is we're not going to get to AGI with transformer models.
Yes.
Which I tend to agree with. I think you're, which is not to say they're not going to be wildly capable and fundamentally change the nature of the work that we do every day, because I think the current transformer architectures are phenomenally good at many of the jobs to be done. Yep. But it does feel like there's going to be a cap in terms of true AGI with the current approaches.
Yeah. Yes, and you made a very important point. Like, just because AGI is not going to be transformers doesn't mean you can't do cool stuff with it. Yeah. I think the transformer architecture is underappreciated. All of us, futurists talk about like, hey, we're going to move off transformer, but we haven't even touched the frontier of what the transformer architecture can do. Case in point, at Blitzy, we're using state-of-the-art models. For example, OpenAI, as of today, this afternoon, launched the latest GPT-4o, which is great at coding. And we're able to leverage these state-of-the-art transformer models to generate 150,000 lines of code in a single run.
Right.
And these are like, if it's 150,000 lines of code, it's about a 12-hour run, and 10 hours of that is thinking time. It's system to AI that has been pioneered by OpenAI in the beginning, when they talked about the O1 and the 20-second thinking time that it comes with. Well, we've taken that many steps forward and applied that specifically to code generation. And now 150,000 lines of code is about the size of a medium-scale enterprise app. And we recently generated Mint, for example, as one of the examples on the public repository. We can build complex apps that way. So, and I'm sure, when you talk about agentic AI, there are many other applications that can, leverage existing models and do cool things that are hard to imagine with, what we've seen so far in today's landscape.
Right. And I think one of the interesting things about the 12 hours and the 10 hours of thinking time is, again, this is the shift in mindset when you're building an agentic application versus a traditional SaaS application. So all of application development for the last 30 years has been decreased response time, decreased response time, decreased response time. And suddenly you just said there's a 12-hour response time. and so that means that you need to really redefine the user interface. You need to redefine how people interact with these systems, how they think about reviewing the work, how they think about quality, how they think about evaluation frameworks. And so I'm not sitting in front of my computer for 12 hours waiting for a job to be run. I give you a job just as I would to an employee or an intern or whatever. I'm like, please go do this, and they'll come back to me in 2 or 3 days. That's a very different user experience. And I think this is, again, part of the opportunity for new companies is they're going to think about that user experience completely differently. They're going to think about how I manage these employees to get jobs done. And I give them rope, and I give them guidelines, and I give them guardrails, and then within that spectrum, I then inspect the work and see how they're doing, and as they do well at that, I hope, I think the smart founders are thinking about, I can do this job well today, and then that gives me permission to expand scope, and now I can do this other job well tomorrow, and another job even better a year from now. And they're not over-promising. I think the best founders are not over-promising what they can do a year from now. They're like, I can do this really well today, and but I can show you my roadmap, and I can tell you, how I'm going to increase the capabilities of this system such that I'll do more. But I'm not going to promise the more yet, because then you're going to get you're going to get the inevitable AI backlash. So it hasn't lived up to its promise, and so being careful about what you're promising in terms of the capabilities of the system and the jobs you're doing is going to be really important. And thinking about the phasing of which job leads to which job most naturally, and do you do more jobs, or do you do one job even better? That will be a really interesting set of strategic questions for founders as they're building their companies, and it's the depth versus breadth will be the inevitable question, and it's going to be a little bit probably of a stair step, that you'll go a little deeper on one, then you'll do another, and then you go deeper on that, and my guess is that's how it'll play out best from a strategic perspective, but each industry and application will be a little bit different.
Yeah, this is Chip being like, Brian, don't oversell things.
Yeah, that's right. Not that you would never oversell. Yeah.
So we'll do something incredibly dangerous here. We'll give you a live product demo of Blitzy to make your partners jealous for you being able to see the full application built out.
I'm super excited about that.
And we'll check it out.
We're just gonna have to pause for 10 hours while we think.
We ran one last night.
That's good.
That's good. You can check out the output here. Cool, so let's get into, we can just start from scratch here. All right, so we'll walk you through the new product workflow. And so this is a little bit about what I talked about on stage, but
right.
Blitzy can work with new products or existing products. So this one will be somebody starting from scratch. And we'll walk through the example here that we built with the platform earlier this summer. And this is really a medium-sized enterprise application, which is why it's a good, clean sample. And so what the client in this case needed to do, which a lender in New York, they needed to receive 1,000 emails a day, which were lending applications. Inside of those, there's several different documents, and they needed to classify those documents, pull out all the data, put the data into a CRM for underwriting. So they wanted to do this so they could replace 30 of their employees, to maybe repurpose them for other uses.
Right.
But this was a SaaS application that they wanted to build. And so they come in, multi-page application, describe prescriptively what they're trying to do, and then from there we send to small batch number one.
Yeah, and we're building the first step of any enterprise scale software development process, which is the product requirements document. So this is where product managers would come in, review all of the requirements, their functional and non-functional requirements. It takes about a couple of weeks. But here we have a 10-page PRD generated for you in about 3 minutes. And 3 minutes is the time it takes us.
Right. No, that's awesome.
Yeah. And so you can see this is incredibly detailed from a product description perspective. If your product manager otherwise turned this into you, you'd probably promote them. So it's capturing all of the flows, all of the functional requirements. And what we love about this process is we're really working the organization through what they're going to build in a way that they ultimately get organizational buy-in and approval on. And if they forgot something in that first step, they can totally change it.
Right.
And it's a fully editable process.
Yeah, it's a live document. And how do you think about the PRD relative to domains? So could you imagine over time that you've got sort of a fine-tuned, this is an underwriting PRD model, or is it generic enough that you can cover all the different potential use cases?
So the PRD itself is, for us, generalized and generic. What we like to do is for the enterprise, they can bring their own PRD format, and it's completely flexible to what the enterprise wants to do. And so if they have a standard, our document can go and reflect that, and we can work within their process.
Right.
And so the next step for us is to take us down the SDLC, which is bring it to the technical specification document that the architect would otherwise own. And so they edit and approve that system, and then maybe you talk about what's going on in the background.
Yeah, so when you go from something that is meant to be inherently non-technical with a non-technical audience, and you translate that into something technical, there's a lot of factors that you need to take into account. One, if the enterprise is using some existing systems, they would highly prefer to be on that system. They wouldn't want to go to a public third-party provider or even SaaS. So we retain all of those preferences of the enterprise when we build that document. The other thing is it needs to account for all of their best practices in terms of security, in terms of their coding style guides, in terms of their product preferences. If they're an AWS company, they would want to be an AWS company, for example. If they like to use MongoDB, they would like that to be the default.
Nice plug.
And
we should just have that be default in the system, would be good.
Yeah, we should talk to them about that.
Yeah. So we have a bunch of defaults on our end
Right.
that we choose for you by default. So if you're a non-technical organization that doesn't have their preferences for product X, we have a default choice for that and we will pick that.
Right.
But if you have your own preferences, we'll incorporate that. So this is a process that typically takes a couple months with a large engineering team, and you come up with a technical specification that calls out every single detail of the product as much as possible. And what you're seeing here is a live example of that, where we've covered all the flows. There are detailed diagrams, including database charts and flows and API documentation, all of that brings this application together.
And this is ultimately what feeds our engine. So the other steps are abstraction layers to get you towards this and get aligned. But this is what our system ultimately sees. And again, if you forgot something or you want to change something, this document editable just like the last one, and you can approve and continue. And so this is where like the real work of the product is kind of a very simple UI experience to power a very powerful technology. And so we're building 80%, sometimes up to 95% of these applications for folks. Maybe you can talk a little bit about what's going on in the background, Sid.
Yes. So what we've done essentially is, we've invented a system that can dynamically assign agents to tasks by estimating the amount of complexity involved in the task. So you've given us this 20, 30 page technology specification. We've looked at it in detail and analyzed it. We've solved the problem of the input context window where, if it's too long, the models don't understand it, but we've developed a chunking algorithm that solves for that. And from there on...
And are you chunking by each of the different components of the technical document, or is it...
Yes. So it depends on the format. If they're using Markdown, we may chunk by different sections, but we focus more on the logical sections of the document. Like one section talks about the database. Great. That should go to the database agent. One section talks about the front end, the design. So that goes to our front end agent. So we have specialized agents for each component and each group of the architecture. And we recruit those agents on demand so that we're always operating in the optimum window of the LLM's context window and their output token limit.
Right.
And if your project is complex enough, there can be up to thousands of agents. Like, for example, the 150,000 repo that we recently generated was about 3,000 agents.
Got it.
And these agents are working nonstop. They're first thinking through it, and each agent is reviewing every other agent's work to make sure that they're always grounded in the technical specification and the software requirements. And by the time we run through this process, we now have planned all of your project in detail, and we're ready to move into code generation, which we do. And after we generate your code, we validate it to make sure that there are no errors, and so that you don't have to go through this workflow. You may have seen videos on YouTube where people use Cursor to build stuff, and they spend days on it, which is still great. You can build a nice small applet in days, but in every step of the process, you're giving some code to the LLM. It's giving you an output. You try to compile it, it has bugs. You go back, you get something else. By the end of it, the product is not what the initial prompt said, but maybe it works. But we've solved for that process for you. So we spend the hours on our end so that when you get an output, it's ready to compile right away.
Right.
Sid uses the royal we because he talks about the agents like they're our employees.
Yeah, you do. You have 3,000 employees that are building.
3,000 are a ton of us.
And how do you think about maintaining quality in the handoffs, if you will? So if you have your database agent and your front end agent, that's a bad example, and they need to be well coordinated. So do you have an orchestration framework or a coordination framework?
Yes. So that is the primary thing that enables all this. So the orchestration between two different kinds of agents, and then there's validation, where we have these generalized agents that are grounded in technical specification, and they're validating everyone else's work. And when they find the gap, they need to assign it to the right agent who created the problem to have them solve it. And that agent has the right amount of context to solve the problem, because, for example, if it's a database error and they made a particular decision, you can pinpoint the gap maybe in the requirement where something was unclear, and that led to the problem. So that also helps us improve the system, where we can improve our onboarding guides and tell customers, hey, be more specific with this particular pattern so that you get higher quality outputs.
And so when you talk about sort of 80, 90% project completion, if you will, you're not only saying that, but you're also able to tell the customer, like, here's the 10% that's missing?
That's right, yeah. And so right when they open up their repo, documentation is the first place that we start for folks, and we can tell them how much that we did. We nailed this one, we got 95%, and then all the way down here on the bottom, we'll task all the human inputs that are needed and the importance of those. And then what's really nice is if you go into any of these specific files, there's a lot here, you can see that human task was in the project guide. We also highlight it directly within the file so they can easily find it and then execute that in a way that's really easy for a junior engineer. And the other part that we really love is we are tying the requirements address to every specific file. So for the first time, we've mapped requirements to code really neatly, which unlocks a lot of capabilities for us. And otherwise, the code is incredibly clean. We can guarantee no circular dependencies, which not even a Copilot can do with a few thousand lines of code. And otherwise, we sort of specialize in a number of key languages where we focus on precision and are always sort of expanding that. So maybe you can provide a bit more color or context on what Chip is looking at.
Yes. So at the moment, we natively support TypeScript, and TypeScript is special because you can build both front ends and back ends with TypeScript. There are frameworks for each of those. But on our roadmap, we have Python, which is about to be supported in a couple of weeks. We have Java, PHP, and C#. And these are all the enterprise languages.
Right.
We do this specifically because there are a lot of nuances in software development. It is not easy. It is one of the hardest things to do. And we attack it on the framework level. We make sure we compile all our code pre-validated so that when our customers, developers work with the code, they're working with much higher quality outputs and they're not spending most of the time figuring out how do I fix this code, because that's what leads to rejection rates. If you look at the studies with copilots, what is the percentage acceptance rates at the copilots?
It's less than a third,
less than 30%, right? So if you're burning all those tokens and you're only accepting 30% of it, that's not a good experience. So that's where the user experience factor comes in. We aim to get to at least 80 or 90% acceptance rate in our outputs.
Right. No, it's fabulous. You've come a long way in the last few months, so this is good to see.
It's been some long nights, yeah. I think, we walked through the new product workflow. What's most excited and what we've signed companies up for is using this with their existing products. And so that document flow that you just saw, we create those documents based on their code repository or repositories of their multi-repo. And so we first create perfect documentation for them, and they can go through the exact same flow of adding features at the tech spec level, and that'll show up as PRs for them right in their GitHub. So bring your product, bring your roadmap, and let us autonomously develop against it, because most organizations in the world have products, and that's really how the product was designed from the very beginning.
Yes.
And are you thinking that customers are bringing like true legacy, old crufty code, or is this more, this is my new modern application and I've got 20 new features and I only have resources to support the development of 10 new features?
Yeah, the last 2 weeks we've done both. The fundamental technology is the exact same to solve it. And so for instance, we've built on top of modern frameworks, and then we've also refactored something, Spring 2 or Spring 2 to Spring 3 was like the use case for this large insurance company. And it's the exact same code representation and update process in the background for the agents. They're just recruiting different agents to solve the problem. So it's a little bit of both.
But if you think about the use cases of the platform, there's a 1,000 different ways we could evolve, right? Because as companies, as you build software, as anyone builds software, you accumulate tech debt, right? And you do that because your frameworks keep evolving and your priorities keep changing. You cannot always allocate resources to go back and keep throwing away the old code and refactoring it every now and then, right? Because every resource you allocate towards tech debt, you take off from growth, and you're competing in a tough market. So with this platform, you can send agents behind that. You've already solved the problem. You already know what the correct answer looks like. You have a product that works today. All you need is you want to upgrade that with the latest frameworks while supporting the same use cases and unlocking the ability for your current development team that has a specific skill set to add more features in the future. So you could choose to do that in 6 months using human engineers, or you could do that overnight using Blitzy and focus on the stuff that matters most, which is the new features and growth.
Right. That makes sense. And do you imagine a world where if you think about tech debt, sometimes that sort of flows down into the infrastructure, and so my queuing engine is reaching a bottleneck. Are you thinking that you'll help people refactor at the infrastructure layer?
We absolutely can. So if you think about how modern infrastructure layers are structured, they're IAC, or infrastructure as code, and because we operate at the code level and we are fundamentally following enterprise practices, which are documentation, and we have in the pipeline we have integrations with Jira, Confluence, and other records, stores of record where all of the enterprise's KPI and knowledge is stored. We can work at the code layer or we can work at the infrastructure layer. But the goal really is, this is great for solving a tech debt, and it's also great for adding new features.
Right.
So you can, have us, and there's a third thing as well. So you can also have us look at your code and scan it for vulnerabilities. You can have us do maintenance fixes, and these are all tasks, all of them together, that your developers are not the best use of, because like I said earlier, you're always borrowing time from your new product growth to have these challenges solved for you.
Right.
The generalizability of this has been, I would say, one of the bigger emergent surprises for us. We didn't go out to solve the refactoring use case, and we got asked if we could do it for a company. We said, we'll try it.
Right.
And it worked exceptionally well. And so because we have a perfect representation of their code, all the dependencies, because we have built all of the agents that can otherwise build in any language, and we've built the agents that have the context, it's been able to, I think, do a lot more out of the box before we even fine-tuned agents than we would have expected, which is, I guess, a great discovery for us to figure out. So,
and so, how are you thinking about the roadmap? You mentioned sort of, continuing to drive performance, fine-tuning, other things. What are the big rocks that you see in your, the next year roughly?
Yeah. So UI is a big rock. We generate UI today, but it's fine. It doesn't necessarily represent either the picture you had in your head or your Figma. And so we can today accept your brand guidelines, your component library, but we can't perfectly match your UI. And so we'll be bringing that online in Q1, maybe a little earlier. We'll see. Don't want to oversell our roadmap, but
right.
The ability to not just use Figma, but use any design tool, bring those images in, and then have that perfectly represented as the output from the UI will just dramatically accelerate it. We're excited to use that ourselves for some of our work. And then we definitely see an opportunity in, as Sid mentioned, scanning vulnerabilities. And so this ultimately becomes the system of record for your code. We have a perfect representation of your code and all its dependencies. And so anything that sits between what the organization needs and what an engineer would otherwise do, which happens to be a lot of security for us, we're
right.
in a great position to build that ourselves or partner with somebody that's going to help us on that end.
Right.
And another important item on the roadmap is, we've seen the struggle with the LLMs. The latest models that you use today are trained with a knowledge cutoff of October 2023. There have been a lot of packages since then where there's either been a vulnerability detected or they've just been deprecated. If you're building with LangGraph, for example, most of it didn't even exist in October 2023.
Right.
So your existing LLMs are useless if you're using that to build the platform. But we're using the platform to build the platform. We've been able to solve that because we have a crawler that can work with OpenAPI and that can crawl SDK documentation as well. And we have a graph-based system that we invented that enables us to intercept the code generation step and use the latest libraries for generating the code rather than relying on the LLM's training cutoff.
Right.
So that is, again, another feature that's coming in Q1. We built that first because we believe that's crucial for developers to always have access to the latest code. Otherwise, an experience where you go to Claude or Cursor or whatever platform you choose and you get code, but you can't really use it because it has a security vulnerability.
Right. Right.
And we care deeply about security. We have a very strong software background, and we want to build the best code generation developer tool on the planet. And these are all milestones that we're going to cross in that process.
Right. Now that last one makes a lot of sense. And so, related to that, not just on the security side, if you think about net new application development, a large portion of that is going to be AI, agentic application development, and so you have an incredibly evolving field. The underlying libraries are changing, underlying models are changing, the frameworks are changing. How do you feel like that's going to be a big area of emphasis, or is it going to be more traditional applications, if you will?
I think insofar as it's documented, we can execute against it, which is
right.
what's so powerful about the graphical representation of all of these documents. And so I think we will naturally follow what the most important software developers' work is doing. And it's going to be a lot of AI native software development, which has a lot of vanilla software development around it that is required
right,
to get it off the ground. So, yeah.
Yeah, and I think it's going to be a balance. So in new software development, I think the world is going to change where traditionally you had to build a piece of software and you had to keep building it. So that's what I did at NVIDIA. We built GeForce Now 3 times. We built it once using Angular, and then we built it, it was Angular JS, and we built it using Angular. And then we changed the backend stack again for whatever reasons. and so that was
hopefully your former bosses don't watch
it. Was, no, they understand it. They felt the pain. The whole team felt the pain. It was no one's fault. It was just the technology stack was changing so fast, and the requirements were so hard on us. So it was a very murky road to the launch because it was a 4-year process, and we just kept building and building and building. But that's going to change going forward. You're only going to build something once. You're only going to document something once, and you can recruit teams of AI agents and have them do your work for you, where they're doing the mundane work of staying up with the existing frameworks, updating code, maybe even doing simple feature additions that you can supervise. So our fundamental thesis is existing development is human-led, AI-supported, and what we're bringing is AI-led, human-supported, where the control aspect and the approval aspect of development is always going to be with the human, but the legwork and all of the repetitive pattern-oriented work, which much of software development is pattern-based, it's doing existing things with a different problem definition. That all is going to be agent-led. So humans can just supervise and get work done much faster.
Right. So how do you think about, one of the things we spend a lot of time thinking about is sort of the human AI interface. And so how do you think about code reviews or other mechanisms that sort of will build trust in the AI agents and what they've developed?
We've been leveraging existing paradigms. One of our goals is we don't want to force developers to think with a new mindset and learn something new, because they don't have time for that.
Right.
Prompt engineering is one of the examples, right? If you want to work with co-pilots of today, it doesn't matter if you're tabbing or if you're giving a new prompt to Claude, what you're doing is prompt engineering. And prompt engineering is an art. It's a science and an art, because you need to learn that, and even if you learn it well, you may not get high quality output. So that's why it's also an art. But rather than having developers learn about prompt engineering, Blitzy does all of that for you, and developers work with the code. So that is, so shifts like that. So coming back to your original question, humans can approve using pull requests. So whenever a senior developer assigns a task to someone else or gets called into the process, if you're using GitHub, it's called a pull request. If you're using GitLab, it's a merge request.
Right.
You get to see the diff between the existing code and the new changes that the AI has made. And we like to leave the agentic workflow development up to the pull request.
Yep.
So we'll create the pull request for you. The humans are going to review it and approve it. So that means...
And then it'll run through the same old software development cycle in terms of testing and all that.
Yes. Yeah. We've done all the pre-validation, so we have high confidence it's going to run. We have access to the GitHub, so we know what the tests are, so we've pre-tested it and to save you time. But ultimately, you're the one pulling the trigger. The code does not merge with your code base until a human has approved it. And at that point, you also probably have a sophisticated deployment pipeline.
Right.
So you will run manual QA tests on the main branch, and then you will promote it to the subsequent branches before it gets into production. So we're trying to keep all of the existing workflows and interfaces the same. We're innovating in the space where humans need not focus on, and AI is well positioned to do the work for the humans.
So in the Flybridge land,
we needed it at every portfolio company.
Yeah, you needed every portfolio company. You guys invested in us because you thought we were fast builders, but that maybe we built something interesting. Do we fall in bucket 1, 2, or 3 here before you guys ship?
That's a good question. It's really bucket 1 and 2.
Yeah, no surprises though.
Yeah, that's right. So it's obviously agentic in the sense that you're out doing work on behalf of your customers, and you've found the right touch points in terms of how you interface into their method of working. But obviously you're 2 in the sense of thinking about security and thinking about quality of code and how you develop much more quickly. And every developer platform that we've backed over the years has always been focused on how do you drive efficiency, how do you drive quality, how do you drive reliability, how do you drive security. And so you're both.
Nice. We got 2 buckets.
Awesome. That's great.
That's right. That's what you're hoping for.
Any kind of closing thoughts for the AI founders out there that are building, that are looking for some advice from the Sage venture capitalists?
Yeah, I think that the building side's the building side. I think the hardest part for all startups is really go to market.
Yeah.
And so and if you do the pre-mortem, if you will, of why don't we succeed as a business, it almost always comes down to go-to-market characteristics, and really talented developers and really talented founders can generally build what they're trying to build. Sometimes it may take longer, and that can be like failure mode, but really honing in on who's my ICP, what are those jobs to be done, how do I think about the sequencing of my initial focus, because I think most companies win by being really focused in the early days and nailing a particular set of use cases for a particular set of customers, and then expanding. And so when do I expand, and how do I think about the process of building breadth and depth in my product and building breadth and depth in my distribution channels is really important. So sort of marrying the product focus that most AI founders have with the go-to-market focus, and bringing that same level of rigor to strategizing, playing out the chessboard, thinking about sources of competitive advantage, thinking about differentiation from the competitive environment. Those are the areas to spend a lot of time on.
Yeah. I think, for us, we think product-led sales is a huge opportunity for this. And so otherwise, the experience that you saw all the way up to code generation is free forever for people.
Right.
So we hope that people will just always use us as the hack to get their PRD and tech spec built for their organization. And then we otherwise let people generate code on a limited basis so they can see the output. We have the advantage of having a product that works and is high quality. And so we want to get over the skepticism barrier as quickly as possible with kind of that middle tier product led. And then when you need to bring your own code into the platform, which is most use cases, that's when you ultimately, for us, become an enterprise customer. So,
yeah, no, I think that makes a ton of sense. One of the other observations we have with anything that sort of is more developer focused, more developer led, you have a brief moment in time to capture someone's attention, and so that timed aha is critically important. And if you can capture that with the 3 minutes we spend on developing a PRD and a tech spec, that's an aha moment. And someone's like, oh wait, now I want to actually invest further and understand this product more. And so I think that's super smart.
Yeah. We just got to keep them there to get that PRD.
Yeah, that's right.
Yeah.
So and there's ways you can have samples. I mean, everybody's got a PRD in their Google Drive somewhere that they can upload and get that magic experience. So I think that's right. The biggest issue that you all have is sort of the obvious one, which is that you have people approaching this very differently that have raised piles of money. And so I think the good news is that they've, I think, done a lot of market education that, AI is actually pretty good for thinking about how do I streamline and drive a level of efficiency in software development. And your approach, I think, is very different. And so cracking that awareness to understanding the difference will be super important.
Yeah. We'll just keep talking to people like you and talking about the product and driving people through the funnel. So any closers, any zingers for Chip?
This was fun, Chip. I think you have, I was telling Brian, this one is probably one of the bloopers, but your name, Chip Hazard, it triggers something, some memories at NVIDIA. Yeah,
that's right. Yeah, exactly. You can do dangerous things with NVIDIA chips, but also a lot of fun things. So this is great. Congrats on all the success. It's been great to hang out.
Yeah, we're just getting started. Thanks, Chip.
Thanks.
Thanks.
Good to see you.
Good to see you.